They mill the graphite mixture as a result of mechanical impact and the abrasive effect of grinding solids on the particles. But such equipment consumes a lot of electricity and requires a long time to process graphite to obtain particles of the required dispersion. And it is very difficult to get the fineness of grinding down to 1 micron or less. Vortex layer devices function on the basis of another approach, which is to use the energy of a rotating electromagnetic field. Ferromagnetic particles move at high speed along complex trajectories and constantly collide, forming a vortex layer. This takes place in the working chamber of the device under the influence of electromagnetic field. At the same time other physicochemical effects occur. Mechanostriction, ultrasonic oscillations, high local pressures, and in a liquid medium, cavitation also. Due to this intensive mixing, ultrafine grinding and activation of processed substances takes place in the working chamber of the device. GlobeCore conducted a two-stage experiment to evaluate the prospects of vortex layer devices for the production of graphite micro and nanopowders. In the first stage, our goal was to mill graphite in a dispersion medium from an average particle size of hundreds of microns to particles whose sizes are measured in the tens of microns. And in the second stage, the possibility of dry grinding of graphite from an average particle size of several microns to a size of less than 1 micron was checked. First we prepared 600 grams of graphite, 1.65 liters of distilled water and 500 grams of steel ferromagnetic particles with a length of 15 and a diameter of 1.5 millimeters. All of this was placed in the working chamber of the vortex layer device AVSP 150 and was milled for 10 and 20 minutes. The samples were examined then using a T-scan Vega 3 scanning electron microscope with a measurement limit of 3 nanometers. You can see the image obtained with the microscope on the screen now.